All right, let's get into it. We're going to pull back the curtain on a pretty wild digital heist. This is an attack that works completely silently, right inside your own browser. This is the story of the Pixel Thief.
So, let me ask you a question that sounds like it's straight out of a sci fi movie. Can one website you have open secretly spy on another one? Actually read the images, the text, maybe even your username? It's supposed to be completely impossible.
And the reason it's supposed to be impossible comes down to this one thing: the same origin policy. You can think of it as the number one rule of the internet. It builds these invisible, super strong walls between all your tabs, making sure that, say, your online banking tab can't be snooped on by that random news article you have open. This whole policy is basically the bedrock of your security online. But of course, attackers have been trying to get through these walls for years. So let's take a quick look at how the old school attacks tried to pick this lock, and more importantly, how the browsers fought back. Okay, so the original pixel stealing attacks were pretty clever, but also kind of clunky. What they do is use these special image filters and then measure exactly how long it took the browser to apply them. It turned out that certain colors took just fractions of a nanosecond longer to process. And with that tiny, tiny clue, an attacker could slowly guess what was on the screen, one single pixel at a time. So the browser developers, they fought back, and their response was honestly fascinating. They dug deep into their own code and patched these little timing leaks. They basically made their rendering engines run in what's called constant time, so those tiny variations just vanished. The attack was dead. It seemed like the guards had finally secured the perimeter. So you'd think that's where the story ends. The invisible walls were stronger than ever. The problem is solved, right? Well, not quite. See, the thieves just found a much, much smarter way in. They basically stopped trying to time how long it took to open the front door and instead started listening to the vibrations coming from inside the vault itself. And this is where you see the huge leap. The old attacks were timing the entire very noisy process of rendering a web page. But Pixel Thief, it does something way more subtle. It listens directly to the CPU's own short-term memory, the cache, to see what data it just used. It's like the difference between timing how long a chef is in the kitchen versus just peeking at which ingredients are left on the cutting board to figure out what they made. The key to this whole thing is called a CPU cache side channel. See, every single time your computer processes data, it leaves these tiny little traces in its super fast cache memory. So by watching which parts of the cache are being used, an attacker can literally figure out what data the CPU is working on. It really is like checking a workbench to see which tools a craftsman just put down. And from that, you can figure out exactly what they were building. Okay, so now we know the technique. Let's break down the actual heist plan. How does Pixel Thief pull this off, step by step? It's actually a four-stage operation. First, they have to trick the browser into using a very specific piece of code that they know is vulnerable. Then, and this is brilliant, they use a two-tab system to sidestep modern security. After that, they send a little secret signal to get their listening tool perfectly in sync. And then finally, they just watch the cache and steal the data bit by bit. So let's look at step one. Modern browsers, they love to use your powerful GPU for rendering because it's way faster. But the vulnerable code the attackers need is on the CPU. So how do you force that switch? Well, in Firefox, they found this simple, almost elegant trick. They just combine the filter they want to exploit with another one, like a blur effect that only runs on the CPU. And boom, that forces the entire operation to fall back to the CPU right where they want it. Now, getting past modern security, that took a really clever workaround. See, browsers now stop a single page from both embedding other websites and using the kind of high-precision timers you need for a cache attack. The attacker's solution? They just use two tabs. One tab has the victim's website embedded in it. A second, completely separate tab runs the attack code. And the two tabs secretly talk to each other by passing messages through the attacker's own server. It's a classic two-person job. So the plan is in motion, the tools are in place. What's the score? What can the Pixel Thief actually steal with all this? The first proof of concept is just amazing. By listening to those faint signals from the CPU cache, the attacker can literally reconstruct an image, like the Firefox logo in the original paper, from a totally separate walled-off browser tab. They rebuilt it from nothing but stolen data, pixel by pixel. And this table really puts it all into perspective. I mean, look at the old timing attacks. They maxed out at about 60 bits per second, and that was usually limited by your screen's refresh rate. But because Pixel Thief attacks the memory directly, it just completely shatters that limit.
267 bits per second. That is more than 4 times faster than the previous record holder. It's not just an improvement, it's a total game changer for this kind of attack. And yeah, it gets worse. This isn't just about stealing some logos. The technique is so precise, it can steal actual text. The researchers showed a full end-to-end attack that successfully leaked the username of a logged-in user on Wikipedia, and that's when this threat gets really, really personal. But beyond images and text, there's another classic privacy attack that this thing just supercharges. It's called history sniffing. That's where an attacker tries to figure out which websites you've already visited. And here's how they do it on a massive scale. The attacker makes a web page with thousands of invisible single-pixel links on it. Now, your browser automatically colors links you visited differently, right? So the attacker just uses Pixel Thief to read the color of all of those thousands of pixels at the same time. Instead of checking one link at a time, they can check if you've been to any site in a batch of 1,000, pretty much instantly. It is history sniffing on an industrial scale. What this all really points to is a much larger truth. We're all watching this constant, invisible arms race happening right inside our browsers, between the people building the walls and the people trying to tear them down. But the fight is definitely not over. Features like Firefox's total cookie protection actually help block the cross-site version of this. Websites can also defend themselves with better security headers, and of course, the browser makers themselves can go back and apply those constant time programming principles to their CPU code, not just the GPU code they fixed before. You know, this quote from the researchers who discovered Pixel Thief just says it all. The game has totally changed. It's not enough anymore to just defend against those old timing attacks. The new frontier is defending against these incredibly subtle, high-resolution cache attacks. The guards have to learn to watch for a completely new kind of threat. Look, what we've talked about here is just one battle in a much, much bigger war for your privacy. Your browser is constantly being updated and patched against threats you'll probably never even see. But the attackers, they're constantly getting smarter too. And it leaves you with one final question. In this crazy ongoing arms race, who's actually winning?